Having Fun with Functions by Hayes Hess and Claudia Doran. A guide through math to help you function just a little bit better. So what is a function? A function just compares one set of an equation to another. Or in simpler terms, it compares the x and the y value of a given quality. We have three basic parts to a function. We have the input, the relationship, and the output. The standard linear equation we usually see for functions is f of x equals x squared. And we know f of x as y. We would say y equals, and in this case, it's x squared. So 1y equals x to the second. And we would read this, as I've said plenty of times now, f of x equals x squared. This is the function name, this is the input, and this is the output. Of course, this equation is not the only way you could write a function. There are many other ways, one of being interval notation. So here are a couple rules for interval notation that you can take a second and read over. But basically, I would just like to go into an example and explain it myself. So moving into an example of interval notation. So this is just one way, this is your standard function inequality. So we're saying x is greater than 1. So everything above 1 is in our function. And this is the exact same thing right here. This is still x is greater than 1. It's just writing it in interval notation. We have the x and then plus infinity. So anything that is above 1, it goes on forever. That is in our function. Now, a part about functions that I hope a lot of y'all remember, because we've done these recently, were piecewise functions. This was when we made the pictures out of using different pieces, of course, piecewise functions. We used different pieces or different equations, multiple equations to draw pictures, and we did that for our last project. So piecewise functions are just a combination of an equation that each correspond to a different domain and a different part of the equation. So for example, we have two different lines in this function. We have two different equations. So this equation right here corresponds with this line, this one with this one. So to make a piecewise function, you just take a whole set of equations and add them together. Transforming a function. So there are four main movements for a function. Starting off, we'll start with translation. So translations, you can move it left, right, up, and down. Those are pretty much the only way to move anything. So, to move it left, it's all inside the parentheses. Horizontal movements are all stay inside the parentheses. So to move it left, we do f of x minus h. To move it right, we would do f of x plus h. To move it up and down, though, everything stays outside of the parentheses. So to move it up, it would be f of x plus h. To move it down, it would be f of x minus h. And here's an example of us taking a function and moving it down 2 spaces to be exact. We have our standard equation, we do f of x minus 2, and then we get our new equation, which is 2 spots down. Our reflections. So moving into reflections, if you want to reflect something over the x-axis, you multiply the y value by -1. If you want to flip it over the y-axis, you multiply the x value by -1. Dilation. So dilations are basically just the compressing and stretching of a function. You're making it smaller and then bigger. So to do this, if we want to make it smaller, we multiply x by a fraction. And if we want to make it bigger, we multiply x by a whole number, above 1, obviously. Now rotations. Rotations are the most complicated ones because it requires a little bit of trigonometry. So first of all, we need to determine what we would like to rotate our value by. So we have our standard equation. We have y equals x. That's our standard function, y equals x squared. Say we want to rotate it 15 degrees. First, we have to convert 15 degrees to radians. By doing this formula, we do pi, so pi over 12. After that, we have to multiply it by x times sine pi over 12 plus 1 and over 12 cosine pi over 12 equals x cosine pi over 12, y sine pi over 12. And that is a formula that you can just write down, and you see we just inputted this right here, but the rest of the formula stays the same. So finding the domain, here are a couple rules that will help you find domain a little bit easier. Feel free to write these down. I'm not going to explain them because they're pretty easy. But is it really a function? So like we said earlier, multiple elements of the input can go to only one element of the output. That is the biggest rule of the function. It is a dead giveaway. If a function has if one output has multiple inputs, you immediately know it is not a function. If multiple inputs have multiple outputs, it is still okay. Well, that is all for functions. Thank you very much.